started. This is chapter 5, section 1. This is about the probability distribution. A random variable is a variable whose values are determined by a chance. So variable means it is any characteristics. It can be number or the quantity that can be measured. So which is called the variable. So typically variable will vary. So it may have more than one value, right? That's what we call it as a variable. So the random variable means which is a variable, but whose values, are determined by chance. So which is called the random variable. So there are two types of random variable. One is you could call as a discrete. Another one is a continuous variable. So now here we discuss about discrete. What does mean by discrete variable? Discrete variables can take only, the limited number of values or finite values, whereas a continuous variable may have infinitely many values. Okay, but here we are going to look at only discrete variables, variables that can take only finite number of values. For example, the number you get, or when you roll a die, so the possibilities, you know the possible values are now limited, right? When you roll a die, we will have, of course, any number out of 6. So it is kind of fixed. We know the values, right? For discrete variable, we are going to find now the discrete probability distribution. That means, we are going to look at the distribution of how the probability values are distributed among, the variable values, which is called the discrete probability distribution. In order to make probability distribution table, so we follow these 3 steps. First, you need to make a frequency distribution for the possible outcomes or values of the variable. Then the second one, you need to find the corresponding probability for each value. This could be determined by dividing the frequency for each value, by the sum of the total frequencies. Then if you want, you could graph those, the pieces of information. That is called the probability distribution graph. So now we are going to look at how to, draw a graph of probability distribution. Okay. So now let's look at this example. Construct a probability distribution for rolling a single die. Remember, my outcome here, x, this is, you could think of your data value. In this case, this is our variable. Okay, what is my variable? My variable is nothing but, the number I get, right? So my variable x is here, the number I get when a single die is rolled. Okay, I'm looking for the number. So this is x. So now we know x can have 6 possible values from 1 to 6. Okay, after listing all the possible values for your variable x, now find out each probability for these variable values. In another word, what is the probability of getting number 1 when is the single die rolled? We know that is only 1 out of 6 chances. In similar way, I could find all the corresponding probability. These events are now equally likelihood events, right? All the events has the same kind of chance, right, or probability. Um, so they make the probability. So that is called the probability distribution for the variable x is denoted by px. So px is nothing but the probability of getting the value x. X can be 1, 2, 3, and also on up to 6. Okay, so now that is there. So there are some properties we will have after making the probability distribution. So we need to make sure that we have these two properties for the frequency, for the probability distribution. Two requirements for a probability distribution: the sum of the probabilities of all possible, events should be added up to 1. The probability of each event in the sample space must be between or equals to 0 and 1. So this one I already have explained you. The probability for each event should be bounded by 0 and 1 inclusively. So now if you let's go back to the first probability distribution table. So this is my probability distribution table. So let us check whether those two properties are satisfied. Ask yourself, is this condition satisfied? That means what? If you add all the possible probability values, you should get 1. That means these are the possible the probability values we have. When you add, will you get 1? Let's see, 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. I have 6 of them, right? Now this is the summation of px, summing all the possible probability values. 1, 2, 3, 4, 5, 6. So if we add, of course, I will get 1, right? Therefore, yes, the first condition is satisfied. Now look at the second condition. Are all px values between 0 to 1? Ask yourself. So if you look at all possible px, yes, my px is now, my px for this problem is 1 over 6 everywhere, right? Therefore, yes, 1 over 6 is the number which is between 0 to 1. Therefore, the second condition also satisfied. So this is my correct probability distribution. So if you are asked to make a probability distribution, make the table like that. First of all, you find possible outcomes for your experiments, then find the individual probability, then check whether these two conditions are satisfied. Okay, check these two conditions are satisfied. So make sure that these two conditions are satisfied. Okay, so now look at this example 2. Represents graphically the probability distribution for the sample space for tossing 3 coins. So you need to, first of all, find the probability distribution, for tossing 3 coins. Okay. So now, when you toss 3 coins, we are looking for what? So I'm making probability distribution here. So the number of heads is my variable here. I'm looking for the number of heads for among these 3 experiments, tossing a coins consecutively 3 times, okay, or tossing a coin 3 coins. So I'm my x is number of heads I get when I toss 3 coins simultaneously. Okay. So what are the possible values of x I have? Well, there are several values now. You may have all tails, so you may have nothing heads. Therefore, x may be 0, or maybe 1 heads, maybe 2 heads, or maybe 3 heads. So these are the all possibilities, right? So these are the all 4 possibilities I may have. X0 means no heads, 1 head, 2 heads, or 3 heads. Now ask yourself, what is the possibility of having no heads? That means all 3 In all three classes, you are getting all tails. There's no heads, right? That means if you look at this corresponding probability, so ask yourself, what is your sample space? Your sample space should have now how many options, how many possibilities. Remember, now you are performing three experiments: first coin, second coin, and third coin. So you could think of, the counting principle says if you have K1 possibilities for first one, K2 for second one, and K3 for the third one, the number of possibilities for all three, experiments is simply K1 times K2 times K3. Remember, when you toss a coin, what is the possibility of getting, what are the possibilities? You may have either heads or tails. There are two. So each cases you will have two. Therefore, if you multiply all two, K1 is 2, K2 is 2, and K3 also 2. So you will get 8. So this is your total possibilities when you toss three coins, simultaneously. Therefore, your possible outcomes are, 8. What are those? You may have heads from first coin, heads from second coin, and heads from third coin. That is one of my outcome. Or you may have heads and tails. Or you may have heads, tails, heads. That means first coin heads, second coin tail, and third coin is also heads. Then you may have H, okay. Or you may have heads, tail. We may have tail, heads, tails, and you may have tails and heads, and you may have all four, maybe all three, maybe tails. Okay, so these are the all possible outcomes you may have. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 outcomes. Among these 8 outcomes, now we are looking for one. Zero heads. All of them are tails, in other words. So if you look at here, how many outcomes you have which are all chase. Yes, I have only one outcome, all chase, TTT. Therefore, the probability of having all chase or zero heads is 1 out of 8. 1 out of 8. To get 1, that means we will have 1 heads. You should have 1 H in your outcome. So if you look at your outcome, where are you getting 1 H? 1 H is here. 1 H is here and 1 H is here. So there are 3, right? Therefore, 3 out of 8 is going to be, having a 1 H out of 3. 2 heads now, I'm looking for 2 H. So I will have 2 H here, here, and here. Again, 3 out of 8. And you should have all 3 heads. Yes, all 3 heads, only 1. So it is 1 over 8. Like that, you have to complete. After completing your probability distribution table, so you have to make sure that those two, conditions are satisfied. What are those? When you add all possible probabilities, so you should get 1. Make sure that you are getting 1. Otherwise, you made somewhere mistake. It is not correct. Yes, if you add all possible probabilities, are you getting 1? 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8. So when you add this, look at the numerators. 1 plus 3, 4, 4 plus 3 is 7, 7 plus 1 is 8. This is 8 over 8, which is 1. Yes, I'm getting 1. Then ask yourself about the second case. Are your px between 0 to 1 inclusively? Yes. 1 over 8 is, between 0 to 1, 3 over 8. All the numbers are now between 0 and 1. Therefore, yes, this also satisfied. Therefore, two conditions are satisfied. This is a probability distribution. Okay? Probability distribution. So that is correct. So I made the probability distribution table. Then, if you want, you could draw the graph. How do you draw the graph of this distribution? Okay, let me take my X as possible outcomes. This is my variable. My variable will have now four different values: 0, 1, 2, and 3. So now make the block with 0. 0 may have with 1 over 8 probability. So I'm making here my y-axis as my probability value. So that is 1 over 8. Then I have 3 over 8. So make a block with 1. So this is the value I'm getting for 1. Oh, sorry, I'm getting the value for 0. For 1, we are getting 3 over 8. So make a 3 over 8. So this is my probability distribution graph for the variable x. Okay, so first of all, you need to define your variable x. My x is the number of heads I'm looking uh, when I, roll, when I toss 3 coins simultaneously. Okay, so first of all, you need to find the probability distribution table. Okay, now let's move to the next problem. A convenience store sells AA batteries in 2 per package, 4 per package, and 6 per package, and 8 per packages. So there are several options, right? One, two, three, four. There are 4 different packages are available. The store sells 5 2 packets and 10 4 packs, 8 6 packs, and 2 8 packs over the weekend. Construct the probability distribution and draw the graph for the variable. Okay, so now let us figure out first, you know, let's define our variable x. And so I'm defining my x as the number of, number of batteries. I'm defining my x as number of batteries in a package. Remember, I have 4 different values, right? So my x have 2, x have 4, x may have 6, or x may have 8. So I'm going to make my probability distribution table then. So my x and px possible values. So I have 4 different values. So my the number of batteries in package may be 2, maybe 4, maybe 6, or maybe 8. Okay. Now for each packages, find the corresponding probabilities. So count how many total packages are. So find out how many total packages are sought out. So the total packages, if you look at carefully, 5 2 packages, 2 battery packages are 5, and 10 of 4 pack batteries, and there are 8 packs of 6 batteries, and 2 packs of 8 batteries. So when you add all, you get 15, 23, and 25. This is total number of packages to solve in that week. So now I'm going to find the corresponding probability. So what is the probability of chance of selling 2 battery packs? Well, there are 5 2 battery packs out of 25. Therefore, 5 over 25 will be zero point 0.2, right? 0.2. In similar way, ask yourself how many 4 battery packs are sold. 4 battery packs are 10 out of 25. So that should be 0.4. Then how many 6 battery packs? There are 8 of them out of 25. So 8 over 25 should be 0.32. And the last one, 8 battery packs. There are 2 out of 25. So this should be 0.08. Okay, so then ask yourself whether all two conditions are satisfied. So the summation of all the px values should be 1, point 2, point 2 plus point 4 is point 6, point 6 plus point 4 is 1. Yes, all the conditions are satisfied. So this is correct probability distribution. Okay. Okay. Now we have the probability distribution. So then you could draw a graph now. So my x is the number of battery per packages, and this is corresponding probabilities. And I have now. So if you draw a graph for the probability distribution, it will have like this, and this is the value we are getting 0.20, the first one. Then this is point 0.4 means 0.40, and this is 0.32, and the last one is 0.08, just below 0.1, right? So this is the way to draw the graph of the probability distribution. So I already have explained about these two properties. So when you are asked to draw a probability, when you are asked to make a probability distribution table, after making the table, make sure that these two conditions are satisfied, right? If it is not satisfied, then it is not going to be a probability distribution table. Okay. So now look at these exercise problems, and for 7 to 12, determine whether the distribution represents a probability distribution. If it is not, state why. Remember, you need to check these two conditions. For each table, these two conditions should satisfy. Otherwise, it's going to be not a probability distribution table. Okay. Now look at the first one, 7. Is this probability distribution? Remember, look at the second condition. All the probability values should be 0 to 1. Cannot be negative. But I see here one negative answer. Therefore, this is not correct probability. In another word, probability cannot be negative, right? Therefore, this is not satisfied. The second condition. Therefore, this is not a probability distribution table. It is not a probability distribution. Reason the second condition, right? So second condition is not satisfied. Second condition is not satisfied. Again, this also the same thing because I see the negative. So it is also not a probability distribution. Reason, again, the second condition is not satisfied. The next one, if you look at all the values are now 0 to 1, that is fine. But look at the first condition. When you add all, it should have 1. So check 0.1 plus 0.3 is zero point 0.4. 0.4 plus 2 is 0.6, and 0.6 plus 3 is 0 plus 9, and 0.1, this is 1, right? So the probability of all the summation of the values are now 0.1 plus 0.3 plus 0.2 plus 0.3 plus and 0.1. So this is adding up to 1, right? So it is a probability distribution. Okay, both of the conditions are now satisfied, and all the px values are now between 0 to 1. Look at here. What about the next one? Okay, so check whether you are getting px summation is 1. So I'm simply adding all the px values, 0.05 plus 0.35 plus zero point 0.4 plus zero point 0.2. You get 1. This is zero point 0.4, zero point 0.8 plus 2. Yes, I'm getting 1. And moreover, all the px values are between 0 to 1. Therefore, both of the conditions are now satisfied. So it is. The next one, what is my summation px? Add all the possible values, zero point 0.3 plus, zero point 0.4 plus, 0.3 plus, zero point 0.1. Will you get 1 now? This is 0.7. No, now I'm getting more than 1. So that means the first condition is not satisfied. So it is not. And again, the last one, find the summation of all the px. So that is 4 over 13 plus 1 over 13 plus 3 over 13 plus 1 over 13 and plus 2 over 13. So when you add all, you will get 4 plus 1, 5, 5 plus 3, 8, 8 plus 1 is 9, 9 plus 2 is 11 over 13, but this is not equals to 1. You should get 1, right? So therefore, this is also not. So this is the way to check whether the given distribution table is a probability distribution table or not.